Okay. Today we are going to discuss two things, especially in Groovy, and one is closures, and another is the collection framework. And before we start these two topics, I actually wanted to discuss one more thing. We are using somewhere in x int a equals to 10, and somewhere we are doing something like that b equals to 20, right? So what is the difference exactly here? When you actually do something like this, okay, let me get my annotation. Okay, when you actually do something like this, int a equals to 10, what actually happens is that this particular variable a is associated with int type throughout the course of your program. Okay, so anywhere if you fetch a, anywhere you are having a variable in your program execution, it will always be in a type of integer. Okay, so what I mean by that, so uh, let's just write some code and that will make it clear. So we'll come to this one in a moment. So int a equals to 10. I have defined variable a to be of type integer object. Okay. If I do something like this, let's say a equals 2.2. So what do you think will be the type of a once I do 2.2? Any guesses?
Big decimal?
No, it will always be of type integer if you explicitly specify the data type of a certain variable in Groovy. Okay, so even if I'm doing 2.2 here, if I print line a,
Two rounded.
yeah, it will get rounded. Yes. Okay, it will always be 2. And if you just get the class also, it will show you that I'm of type integer. I'm not of type double or big decimal that we were thinking about. So later down the road, if you do something like, let's say 2, okay. Now this 2 is not normal 2, it is actually a string, right? But Groovy is smart enough to understand that this string actually is a number. Okay, inside the string, I'm still holding a number. So I will change my type from string to an integer. Okay, so if I go ahead and again do quickly a, okay, it was, whoa, okay, that's random. I did something. Okay, I was not expecting this. Okay, still integer, but why 1250? Okay, I got it. This actually changed the value to ASCII value of this number 2. Okay, that is the ASCII for number 2. So it actually, so sorry.
Mute everyone. Sorry.
Okay. How do I do that? Can you guys please mute yourself? I'm not able to figure it out from my end. Okay, so this actually is an ASCII. So if you want to convert it this to string 2 as a number, you can do something like this. Okay, and then if you run this, this will be integer, and it will be just what we actually intended. It will be 2, not the ASCII value of 2. Okay, but the point I'm trying to make is that if you are explicitly defining a variable with a certain data type, it will stay that way throughout the course of execution. Okay, now if you do something like this, okay, that b equals to 10. Okay, the moment I change, okay, let me just go ahead and print the data type also here. Get the class. Okay, if you do something like this, it is saying, okay, I'm integer. Okay, now if I did something like b equals 2.2, okay, and then if I do something like get class, it will get changed actually to big decimal this time. Okay, so when you actually use def keyword with a variable, okay, it's like as you go down your program execution, whatever is the data type on the right hand side is actually associated with that variable. This is the dynamic nature of Groovy. This was 1 second. This here is actually the static nature of Groovy. Okay, this works just like we have been coding in other languages, and this is the dynamic nature. Okay, here I have mentioned a equals 10, so it is okay. It is saying, okay, I will associate b with an integer type. The moment I change b to a floating point number, it told that, okay, now I'm going to change my data type to a big decimal. Okay, so that is actually there is a difference between using explicit data type and use a def keyword. Now, I'll show you one more thing here. Now, let me clear this screen. Clear our okay. Okay. Now I'm actually starting with the methods, how to create a function actually in Groovy. So I'll define a basic function here. Okay, and this will be a continuation of what I was talking just earlier. So I'm just saying the name of the method is function. That's a really bad name. Okay, don't care. So def A and def B. Okay, and this is how you actually define a method. And what I'm going to do is I'm going to say def C equals A by B. Okay, so what I'm exactly doing is I'm dividing two variables, and then I'll just return C. Okay, nothing fancy going on here. This is how you define a method in Groovy. Okay, you declare the name of the function, you define a either use def or you'll use a explicit data type, then you list your parameters here, and then in your curly braces you actually run have some set of instructions that you want the method to do. Okay, so if I do something like this func and I pass something 10 and 2, this is good, this will work, and it prints 5. Okay, if I do something like, let's say 3 and 2.2 2.3, something like that, okay, this is fine as well. But what if I do something of this nature? Let's say I have here A, B, C, and then I want to divide it by D, something like this. So I have string here. Since you're using def keyword, it can take it, right? I've just shown you that if you're using def keyword, once you have a parameter that is string, it will change its nature from integer to a string, right? So if you run this piece of code, it will blow up now. Okay, so don't think that if you use def keyword in your whole code in your Groovy, let's say you're writing 100 lines of code and you're not mentioning anywhere explicitly that it is an int or it is a string or it is a double or float, then don't think that your code will still work if you throw up any data type, any argument type to a function. Okay, it is Groovy is type safe whether you are using def keyword or whether you're using int keyword. So the general rule, thumb up rule is, if you know the data types, use it explicitly. That is why when you see the APIs, public APIs of Groovy or sorry, Groovy or ePBCS documentation, if you go through their API, they intentionally use explicit data type because that makes your code much clearer. So if I just changed my this thing to int, and let me comment this one and this. Okay, and if I run this code, it is saying, okay, this was running earlier also. If I comment this one, uncomment this one, it will throw up an exception because it is saying that I'm not able to find a signature of method of which is because you're passing here, this is an integer and this is big decimal. The function you have defined here accepts only integers. Okay, so this actually is more cleaner approach to writing your methods in Groovy. So if you know for a fact that I'm going to be working with a string, then by all means explicitly define your variable to be of that string type. Okay, str equals something, let it be empty string. Okay, If you don't know, let's say where can I use def then? Okay, you can use def if you're calling, let's say, some method and you don't know for a fact that what it will return. So let me just say def def and I'm calling some method over internet, maybe calling some API call sorry, that I don't know. Okay, so by all means, if you don't know something, go ahead and do this thing. Your code will not break, at least, because if you don't know the data type, you cannot define it prior. So here, in certain situation, you can go ahead and use this def keyword. Okay, any questions on this? I wanted to highlight this quickly. Anyone? Okay. One
So I have one question actually.
yeah, go ahead.
So here, if we would like to write any specific condition or whatever, so in that particular situation only we have to use the def, or how it is? Of course, you have used the int, but
Yeah.
it will work only for the integers.
Yeah.
So if I would like to use curly braces and if I would like to define some sort of condition, then I have to use by default like a def. Am I right? Is my understanding is correct?
You can use default, but you cannot pass any data type to that method. Okay, so you can use def keyword. By the way, that's not default, that's def. Okay, so you can write def. You by all means you can write def. Okay, but when I do this, sorry, let me just change it back quickly. When you do this, okay, don't expect your program to run for any data type that you pass to it. Okay, because what you're doing in this method, you're basically dividing. Okay, dividing two numbers. Numbers can be floating, numbers can be normal numbers, like 1 2 3 4. But can you divide a string? Can you divide, let's say, for example, to dog object or to date object? You cannot do that, right?
Yeah.
So Groovy is giving you that luxury to use def keyword, but don't expect your code to work for anything that you're passing. Okay.
Okay.
Yeah. So this will still this execution will still blow up, because there is no such thing as a division among string. So it also mentioned here very clearly that a string does not have a div option. Okay.
Right.
Yeah. So that is actually one thing. Okay. Now that we are here, let's actually one more thing is there. I missed this. This is very this is about operators, and you may see this thing somewhere. So if I have, let's say, int equals 10, okay, there is something called as this a plus plus and plus plus a. It is not very difficult to understand this, but are you guys clear with this, or should I give an example here?
Is this any different from the way Java works?
No, there is no difference. It is exactly the same way.
Okay.
Yeah. Anyone else? So this is actually called post increment, and this is actually called pre-increment. So when you do this e plus plus, what really happens is that the value of this whole thing is incremented by 1, but for the after this statement has finished, it gets incremented, not during its execution. So let me just give you something. Print line print line here. If I do something like a plus 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 e, okay, I'm doing here both. What do you think it will with the output here?
$21.
Okay, at 21, somebody told me. So if you see this, when you do this print line a plus plus, okay, this is 10 still. Okay, once the execution of this is over and it comes to this place, okay, that is actually incremented by 1 once the execution is over. So it's actually called post increment. Okay, so when it comes
22, right, Saurabh? Like
yeah, so it will be 22, but let me just
sure.
yeah. So before we can do this, let's have this print line a plus plus. I'm printing line a plus plus, whatever is the output. Let's see. What do you think it will be? Any guesses?
It should be 10.
Yeah, it should be 10. Okay, but now if I print line a, just a, okay, the value now, this code, sorry, let me get my, this code has already executed, okay, and this is called post, by the way. So after the execution, post this operation, the value is incremented. So now if I print a here, it should become 11. Okay, so if you run this code again, it is 11 now. Similarly, if you have this, let me just comment both of them. Similarly, if you print line a plus plus, okay, sorry, plus plus a, okay, this is called pre-increment. So it will first increment the value of a, okay, and then it will print that value. So if I print this, it will be what happened? Did I do something wrong? Okay, this is the problem with Groovy. Okay, always give parentheses. Actually, if you don't understand how, sometimes this will complain that println is not working. Okay, so give parentheses always. So this plus plus a, if you are using before the variable, it will increment the value and then it will print the value. Okay, so now coming back to this one. Okay, let's see what is done. When we are here, this particular thing, I told you this is post increment. So this will be here, it will be 10, but the moment it comes around this part for further execution, it will change its value to 11. Okay, and when it comes to this particular portion here, this is pre-increment. So 11 will convert it into 12. So 10 plus 12 will actually be 22. Okay, so that is what is happening here.
So Saurav, can you do one thing, that can you add a plus in the increments in the left side? I just need to see that it is from left to right or right to left. It is calculating in the same script only. A plus, then a plus plus, then a plus plus.
So you're saying this plus plus e plus e plus plus.
No. In the last 12th line only.
Okay.
Just add one more a in the left. A plus. Simple a.
This one?
Yeah.
Okay. So what do you think will the output first?
For me, it should show that 11 and 11 to
33, I believe.
I believe it's 32.
32, I guess.
Yeah,
It should be 32, right? Right.
11, 22, and then 12.
Yeah.
So,
yeah.
but Saurabh, like first it was 10, right? Then it went to A plus plus. It was 10. Okay, it was 10 only. Okay, then it went to here. Then it became 11. Then 12. Okay, got it. Yeah.
Is it clear for everyone?
Yeah, got it. Clear.
Here you have 10. Here you have still 10, but the moment it reaches this side, this post has worked on a post increment. Okay, so here it was still 10, but when it reached this plus here this side, okay, this increment has already happened. And when it came to this plus plus a, this is pre-increment, so 11 got converted into 12. So total 10, 10, 12, 32. Okay, and similarly there is negative also, post increment and post decrement and post pre-decrement. So there is something called as minus minus a and a minus minus as well. So it works very similarly. Post and pre concept are same, only that it reduces your value by 1. Okay, so yeah, all right. Is it clear for everyone?
Yeah.
Yes.
Okay.
Yes, Saurabh.
Good. Let's actually define some methods and then we'll start with closures, because closures actually are very similar to methods, but we also have some added advantage with using closures. And Groovy API or ePBCS API is filled with closures. Okay, so without closures, there's no skipping in Groovy. So let's just define some method first. So I'll just define a method like this. Okay, and I'm using def for my purpose, but you use explicit when you're defining your methods. All right, so here what I'm doing is I am defining another variable, which is the addition of two variables. So I'm just saying a plus b, that's all. And I will use return, okay? How do you call this method? Well, I'll just name the method. I'll pass the parameter. Let's say I'll add me 10 and 20, okay? And if you run this 30, nothing fancy about this. But in Groovy, the return keyword is actually optional. Okay, you don't need to specify a return keyword. Okay, so if I just comment this part and run this, it still prints me 30, because if you haven't provided return no, the last statement of your method is actually the return value. Okay, so here this def, once I commented this part out, this def actually became the last code in my method, in my this method. Okay, so this is actually return. Okay, so this still works as you expected. Okay, so return is actually optional in Groovy. All right, what else? So you can also specify default values for your arguments. So you have, like, let's say two arguments here. You can specify default value if you don't want to pass it. So if I don't want to pass it, let's say equals to 10, and 1 second. Okay, equals to 10. Okay, and if I pass, okay, let's make it something like 5. Okay, so when I pass it, when I call this method using something like 10 and 20, this default value is actually overwritten by 10. Okay, but if I don't want to pass that, if I simply pass 20, then for A, Groovy will assume this default value, and for B, Groovy will take this value in consideration. So if you run this code, first will fetch you 30 and the second will fetch you 25. Okay, so let me run this first. And okay, what happened? Okay, so this is actually printing 30 and this is actually printing 25. Okay, so that is how you use the default value in Groovy. Okay, everybody clear with function? Function is very simple. We have used it a number of times. Nothing complicated about it. So if you're clear with function, we can start with closures now. Okay. Anyone, any doubt before I move on to closures? Hello?
Go ahead, sir.
Okay. Okay. Can you guys give me a minute? I need to get some water. Just 1 minute. Yeah, sorry. Let's begin with closures. Okay. Closures are actually objects in Groovy, which is actually a block of code. Okay. So let me get my listing. Yeah. Yeah. Let me annotate. So closures are actually object which is nothing but a block of code here. Okay, so by default, objects have two things. Okay, they have data and they have behavior. Behavior is nothing but methods. Okay, by default, object have these two types. Okay, but Groovy closures are actually object which is basically built for behavior. Okay. This is actually used for behavior. Okay, so let me start with coding and then it will make more sense to you guys. Let me clear my drawings. Get rid of this. Okay, so without saying a lot of things like objects and all those things, I know that is confusing. Let's just start with using closures first. Okay, so I'll define a closure, and how you define it is this way. So you write something like, remember how we had methods where we actually had curly braces, just some method. We did something like we passed some parameter here in a, and then we had a method like this. So this is actually a method in Groovy. Okay, when you write close and then equals to, and then use this curly braces, by default it becomes closer. Okay, so if I wanted to print the type of you can check if it is an instance of closer or not, so we can do that. So I think this is right. So this is actually a closer. This is how you define a closer, by the way. So you have used this thing of, so let's just, I did this, right? So instead of doing just 10, instead of giving data, I'm going to give it a behavior here in this curly braces. So it is very close to your general variable that you have in Groovy. And we'll talk about why this is more important and what other flexibility this offers. So let's just comment this part. Yeah, okay. 1 second. Okay. Okay, so let's this is not very valuable closer, by the way. Okay, it is doing nothing. So if I do, how do you call a closer? Well, you just say, just like your method, how you put this parenthesis on a method, just like that you actually call your closer. So if I run this part of code, well, it doesn't do anything because there is no behavior here, right? So it won't do anything for the time being. There's another way you can call your closer, that is using the call method. Okay, nobody uses that, but just for completeness, I'm showing you guys this. Just go ahead with this one, just like you call your method. You should call your closer as well. So let's actually create a closer that is worthy of doing some work. So what I'm going to do, first thing is I'm going to define a closer. Okay, and this thing just gives me, it just prints something, hello from closer. All right, so this is a closer that I've defined, okay, which is just going to print me something. So how do you call this? Well, just like a method, I'll execute this piece of code and it actually tells me hello from a closer. Okay, nothing fancy about this as well, but we can pass arguments just like we have done with methods. Okay, wow. I got scared there for a moment. Can you guys mute yourself? Okay. All right. So this is a closer, by the way, and it is actually doing some work. Not like completely. This one is completely useless. It's doing nothing. This is doing me a valid printing statement, just like I would do with a method. I'm just passing a simple print statement to my closer, and when I'm calling this closer, it is actually printing me something. Okay, now what I'll do is I will pass an argument to my closer. Yes, just like you pass an argument to a method, right? You just prior to this we were talking about adding two numbers in a method or dividing a by b or a plus b. You can do all those things in closer, but let's go there slowly. So I'll pass. I'm just writing first and second. Don't write such name for a closer. It is usually you should give meaningful name. Okay. How do you pass this thing argument? So I'm going to pass name, and then you have a separator. This is an operator which is used in closer to separate your argument with the code of closer. So here I'm going to do print line. I'm going to do what? Hello. And then I'll pass. Remember the string interpolation we spoke about yesterday, the G string. So I'm going to pass a name to it. Okay. And how do you do that? Well, I'll say hello article, for instance. Okay. And if I run this piece of code, it says hello Oracle. I can pass some other value as well. So I can pass hello Kumar, and it should run exactly in the same way. Okay, first hello Oracle and then hello Kumar. Okay, so this is actually closer. But if you're having just one argument to a closer, okay, if you just have one argument, then passing a name, a passing argument is actually optional. And what I mean by that, so let's define a third one. Third, this is again a closer. The moment you do equal to curly braces opening and closing, this becomes a closer. Okay, so here I'm going to do just print line it. Okay, print line it. Okay, and if you run this third, and I'm passing here Saurabh, and if you run this, it will print you Saurabh. Okay, just a minute, let's run that only. Okay, so by default, if there is only one argument to a closer, you don't need to mention it. Okay, Groovy has a defined name for that variable. Okay, if there's only one, only in that case you can say something like this. Okay, if you have more than one parameter, and we'll see that in action in short while. Okay, where we are passing 2 or 3 parameters to a closer. Okay, then you have to specify. If you're passing multiple arguments, you have to specify that. If you're passing just one argument, just one, then Groovy will take care for you, and you can simply use the keyword it. Okay, you can also do something like this. So hello, and instead of $name, you can use it. Okay, and if you run this code, just this one, okay, it will say hello Sora. Okay, that is valid when you have just one argument. Do not depend on it if you have more than one argument. So I'll show you that. Just give me a moment here. Let me get some real estate first. Yeah, the def fourth equals to, let's say I'm passing here first name, right, and last name. Okay, and this is the separator, by the way, between your argument list and your closer code, the real code that closer will work on. Okay, and here we can do again print line something like dollar first name, dollar last name. Okay, and you can call it again the way you have called your method. So you can pass here maybe something like something like this. Okay, and if you run this piece of code, it is working absolutely fine. We are passing 2 arguments. Okay, once you have 2 arguments, once you have 2 arguments, something cancel. Once you have 2 arguments, once you have 2 arguments, okay, you cannot use it inside your closer body. Okay, the it that we were using before, this is implicit by nature. Okay, but just to be for completeness here, okay, it is not a keyword. Okay, so if I do diff it equal to 2 and I did print line it, okay, this will actually print me 2. Okay, because it is not a reserved keyword, but it has got a special meaning in terms of closer. Okay, it stands for implicit, by the way. Okay, so if you're not passing an argument, it will assume it. Okay. By the way, the keywords are something that you cannot use for your. So if you do this something like this, int is a reserved keyword, and if you run this piece of code, it will blow up saying some unexpected input. Okay, so those are keywords. There are multiple keywords, and you can go to Groovy reserved keyword, something like this. It will take you to I think there's some proper documentation is there. Somewhere you can figure it out from here. I'm not going to show you that, but there's some list of 50 odd keywords that you cannot use as a name of method or as a name of variable or as a name of classes for that matter. Okay, let's jump back to closures. Okay, and is it making sense so far? Closures. It is just like a method where you have arguments this side, and then this is a separator between your arguments and your actual code, and that's it, to be honest. And you're calling it just like you would call your method. Okay. Anybody any doubt?
Now, when will you use closure and when will you use method, Saurabh?
Okay, so yeah, that's a very good question, and I'll come to that in a moment. I have told this earlier also. Yeah. Can I get a new one? So, where's, yeah, let me annotate now. Okay. Groovy closures and function. There is a huge difference between closures and your methods. Okay, I'll just write C and M, so you can understand the difference. This is your closure, this is your method. Okay, Groovy, this is a piece of code, a structured code. Like you have a method, you define something, let's say func, and then inside that you wrote a piece of code, and that's it. This is not an object. Groovy closures actually are objects. They're actually first class object, to be honest. Does anybody know what first class object means? First
No.
class. So first class means that, well, just like we have first class, second class, third class citizens, they call it, right? So just like that, Groovy's objects are also defined that way, first class. Okay, so what does that mean exactly, first class? So first class, what it means that you can pass a, let's say I have int a equals 10 here. Okay, a is a first class object in a sense that I can pass a to a method. Okay, and I can return a from a method. So I can write return a, and this will return as well. So Groovy's closures are actually first class object in that sense that I can pass it to a method, I can get it returned from a method as well. And we'll come to that. I'll show an example of that, couple of examples of that to make that more clear. Okay, 1 second. Okay, so we're talking about closures and methods. Okay, method is just your again, we have defined some method and we are doing some work and all those things are happening here. Closures are also similar, right? You're passing argument to them, it is doing some work for me, and then it is returning something. What makes this more special than method, and why should we consider studying about it? Well, closures can be passed to a method. Okay, as an object, closures can be passed to a method. Okay, and then you can return a closure from this method, and this has actually a huge if you are familiar with something like lambdas in Java, closures are more like that, only with more capabilities. Okay, let's not go there. I'll show you with an example. I know this is not making sense to a lot of us, so let's just go there. Let me clear everything. Let's close this. Let's go here. All right. Okay. I will define a method. I'm not defining a closer, by the way. And how do you do that? Well, method, I'll pass a argument to it, couple of arguments. I'm going to pass a number here, int num, okay? And the second will be a closer, okay? I'll pass a closer to it. And what it will do is I will pass this number, whatever this number is, I'll pass that to a closer. Remember how we are doing this thing here. This is my closer, okay? Print line, hello, it, and then I'm passing an argument to a closer. Similarly, I can have a closer C and I can pass something to that closer, okay? So I'm passing here a num, let's say, okay? And that closer will work on this number for me, okay? So let's just see that an example of this thing, okay? So I'll say method, okay? I'll call it with let's say 10, okay? And closer, I'll define a closer in a moment. Let's just define that. So def closer, okay? And what it is essentially is doing is it is printing print line. I'm passing a number. Let's just pass this num, make it explicit. Okay, print line. Something like I'll just multiply this number with 10. That is all my closer is doing. That's it. Okay. So first, before calling this method, okay, let's call this closer and see if it is working fine. So how do you call that? Well, closer. I'll pass, let's say 5. Okay. So 5. 1 second. Yeah, 5 will actually come to this number. Okay. And this number is 5 here inside of, just like your method, you have passed an argument. And this is the code block of your closer. So num is 5. 5 times 10. This would actually print me 50. Okay. So let's just do that. And it is 50. Okay. 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 Now let's comment this out. And this is where actually closures are more interesting. We can pass it to a method. Okay. So let's say I have a method defined here, which is accepting a number and a closer. Okay. And if I run this piece of code, okay, if I run this piece of code, no, sorry, what did I do? Okay. Okay. I'm passing 10 here. So I was passing 5 earlier. I'm passing 10 here. Okay. 10 actually went here. Okay. And I'm passing this closer object. This is an object, by the way. Okay. This closer object is passed to this C here. Okay. Then C and num here. I'm calling this closer like we have done earlier here. Okay. And I'm passing num. Num is how much? Num is 10. Okay. So once I do that, this will come to this one, this code block where we have defined closer. Num will be assigned the value of 10. And what it exactly is doing? Well, it is printing 10 times the number. So num is actually 10 here by coincidence. So 10 times 10 is actually 100. Okay. So closers can be used to pass to a method, and they can also return from a method. Okay. So I'll just show more examples of this to make it even more clear. Okay. And one more thing before we move on to some other examples is that if the last statement, if the last argument to your method is a closer, okay, then you can call it this way also. So method, right? And this is where it gets weird. Okay. You can define your closer here. So let's say this time I'll just do something like print line it. Okay. So if I run this piece of code here, okay, what do you think will happen? First is 10 that I'm passing to it. Okay. This 10 that we are passing to the closer. Okay. And this is actually something like this. Okay. If closer is the last argument to a method, no, okay, you can pass it this way. without in the parenthesis, okay, outside of the parenthesis. So if you run this piece of code, okay, it will print 10. Okay, this will execute this piece of code on this method that we have passed. Okay, it's confusing a bit, I understand that. Let's even make it more clear with some examples. Okay, we'll talk about collections in a moment, but let's first do this thing. Okay, lists are simple, 1 2 3, very simple list.
Saurabh, regarding that closure, I mean, we can instead of writing closure, we can call one method inside another method, right? So, can you give the real-time example where exactly we need closure?
You
Because that's the piece. If we relate that as the block, right? So, if we can perform what method does inside the closure, then we can define two methods and can call the other method inside another method, right?
Yeah, you can do that, but can you pass it to another method? Let's say, okay, you are thinking in terms of only method. Imagine you have a whole thing, like you have a class and everything, okay, and you want some piece of some block of code to work on a certain object, okay. What will happen in that case? If I want to pass a block of code, it's more like okay.
Can you give one real-time example? I mean, where we should go for the closure?
In Groovy, everything actually, if you just go through API, everything is on closure itself. So even their API, so something like this, if you use, okay, let me just show you 1 second. Okay, let's just do this. Okay, nums, print line, nums. Okay, so if you have this piece of code, okay, contains a variable the name nums. What? Okay. It will print you this thing, okay. But what I was saying earlier is if you have a closure as the last statement, as the last argument to a method, you don't need to use this parenthesis, okay. A simple this thing will do the work for you, okay, without using parenthesis, okay. And it does the same work for us. Coming back to that question, okay. So imagine this is more like, have you worked with the anonymous block of code before?
No.
Okay, so there's something, this is actually more useful when we are doing something like functional programming, right? Where you can pass a function, something like that. Okay, I'll not go in that part, but let's say you have some methods defined, okay? And you are passing two variable to it, okay. You can do whatever you're saying that you can do. Can you do something like I understand where you're coming from, so whatever this closure is doing, you can declare a method of that, okay.
Yeah.
And then call that method as well, right? So maybe this is the method, and then you're saying, oh, can you do func, some func is defined, right? Some func method, and then you pass this value to this one, right?
Yeah.
Right, you can do that, okay. But this is closures were introduced to make a piece of code work as an object, okay, so that it can be passed to a function, it can be passed to a method, it can be returned from a method, okay. So if you have something defined in somewhere, okay, and that is a closure, okay, you can simply pass this as an object to a method, okay.
Okay.
This whole thing can be passed like an object. This whatever is written, whatever you have written in this piece of code, this can be passed here, and it will work as an object. It's like just like it would work with in double and all those things. It would work with closure as well.
Okay.
This is also a valid thing, okay. Of course you can go ahead and do this thing. You can definitely do create some other method, and then you can call that method inside and then pass this parameter, okay. But closures offers you more flexibility in terms of this is an object, so you can pass it to a method, and you can also return it from a method. So there's a difference between your so let me clear everything. There's a difference between function and closures here. Okay, you can definitely do what you are saying, like writing your piece of code in a structured content, but if I have closure, why would I do that, to be honest? Why would I continue keep on doing this function everywhere? I can just pass this and okay.
Saurav, just correct me if my understanding is not right here.
Yeah.
A closure does a set of functionalities. Okay, it performs a set of functionalities. For example, it calculates a current weather condition. For example, it makes a call, a REST API call outside.
Mm-hmm.
It calculates weather current temperature of a particular city.
Okay.
Stores into an object.
Mm-hmm.
If we have a requirement wherein we need to just keep using that as an object value or an object reference in subsequent various functions, then you can just use it as a calculated method that is stored as an object that can be referenced everywhere. Okay.
Yeah.
So is that one of the major usage of closures?
Yeah, that is actually true. One thing is also that just like your lambdas or something, you can have you heard something like anonymous block of code?
Yeah.
Yeah, so closures is very similar in that fashion. Okay, like we are defining this is a closure here. Okay, we are doing this some work here, we're iterating over a list and printing the values of each item here. Okay, this is a block of code and it is anonymous. We haven't declared a name to this particular closure. Okay, so wherever some kind of anonymous block of code is required, you can go ahead with closures. So this was actually coming back to the earlier question. Closures were actually introduced before lambdas were introduced in Java. Okay, so this was meant actually to use it in some sort of functional programming aspect. Okay, closures were actually defined, and then because of because of closures, this lambdas actually came into existence after closures were introduced in Groovy. Okay, so the ability to use a piece of code, like a certain piece of code and an object, was later actually integrated with lambdas. Okay, so it is more to do with using a block of code and as an object, and you can of course do a lot of things without closures. Okay, but if you are studying Groovy, you'll have to learn about closures, because their APIs are filled with closures. Even if you go and see something like list or something like maps or anything for that matter, all of their method like H, or I'll show some more examples. Even yesterday I showed some method like a step or down to on numbers, and they were all using closures. Okay, so that is one use of closures. Any doubt? Hello.
No, Saurav, please proceed.
Okay. Okay, so we were talking about closures. So we have seen how you can call it here, right? This one. Is this clear to everyone? This piece of code?
The one thing which is not clear there for me, right? What do you say? C of num, right? Line number 31, right?
Yeah.
Okay, so that's something which is not very clear to me there.
Okay. Okay. So let's go this. Let's copy this part of the code and this. Okay. So I have defined a method signature here. Before even doing that, I have defined this closure here, right? At least this is clear to everyone, right? What this is doing.
Yes.
Okay. So I have defined this piece of code and I'm calling it as a closer. So I will just do closer here and I'm passing here, let's say 5. Okay. So at least for this one, you expect this to give it a value of minus of something. What do I do?
Yeah, print ln that spelling mistake. Line number 6.
Full code.
No,
Yes.
that's correct.
You didn't select the full code, so
Sorry?
you didn't select from dev, I think. You selected 6 to 9 line. It have 5
Okay.
to 9.
Okay, yeah, okay, yeah, selection issue was there. So this is actually fine, right? Everybody gets this much at least, right? This part of the code. This is your normal closer. You're just passing a number to your closer, and then in the closer body, this again I've told you you can pass your arguments here, and after this separator, you actually run your you actually have a set of code that you want to execute. Okay, so this is fine, right?
Yeah.
This from line number 5 to 9, I'm specifically asking that part.
Yeah, this is clear. Yeah.
Yeah, this is clear. Okay, now because closer is an object, I can pass this closer to methods. Okay, I can pass it just like I would pass an integer, just like I would pass a string. Closers are first class objects, so it is treated just like you treat any other objects in Groovy. So I can pass this closer to a method. Okay, and that is what I'm doing here. So this is my method signature. First is the number and second is the closer. Okay, let's not come to this part here. Okay, I'm just passing my a number, and instead of okay, you have func here. Okay, you're passing in a in b, right? So let's just let it be empty. Okay, so for this one, how you're passing exactly? You're passing 10 and then you're passing 20, whatever. Okay, so you're passing two values and you're comfortable doing this because you understand that both are objects and I can pass it to this method, and that is how the method signature is here. Okay, for this one method int num and closer c, okay, first is a number that it is expecting, and second it is expecting a closer. Okay, so for that one we can say something like method, okay, and I will pass number. Let's take a number 20 this time, and then it is expecting the second expectation of the method is a closer. Okay, so I'll pass a closer to it. Okay, which we have defined here, by the way, on the line number 5. Okay, these two will go and they will actually num will now be occupied with 20 data, and this c, this particular c is not a data, it's a block of code, and that is occupied by this closer here. Okay, so think of this c over here having this whole code inside of it. Okay, this, when you're passing this closer, okay, as here, this is going to this variable here, right? C argument. Okay, just like you said that num will be equal to 20, this c will be equal to this closer. And what is this closer? And what is this closer? This closer is whole block of code. Okay, now this block of code is represented by c, right? So just like we were calling closer 5, here inside I am saying c number. Okay, just like we were calling without doing any method, without doing any method call, just like how we are doing this thing, and this was outputting, this was giving me 50. Okay, so instead of writing this closer as c, let's change this name to c. Okay, why not? Okay. Oh. Okay, now one second. Okay, if this is clear for everyone, can I get yes for this one at least?
Yes, yes.
Okay, okay. This is clear for everyone. Then after this piece of code is done, I define this method. Sorry, I define this method here. Okay. And this is accepting two arguments, right? One is number, another is a closer, right? How do you call? Like here, what we are doing exactly? I have two variables here, A and B. I passed 10 and 20. A got how much? What would be the value of A inside the method?
A is 20.
A is 10, no, first one here.
Oh, sorry.
Yeah.
Okay.
A is 10, B would be 20, right?
Yeah.
Yeah. And you're comfortable doing this because both are objects and you're able to pass it easily and you're able to guess it out, right? Because they are just data and it makes sense. Okay, 10, 20, whatever I'm doing in this method, maybe doing addition, subtraction, I don't care. It will be able to do the work. Okay. 1 second. Now, for this one, the signature of the method is the first argument is a number and the second argument is a closer. Okay. So when I said first number is integer and I'm passing here 20. Okay. So you know for a fact that num will be equal to 20, right?
Yes.
That is clear. Second argument is a closer. And what I'm passing here C. Okay. I'm passing here C. So this C will be actually equal to this one, right?
Yeah.
Yeah. And what is this C? C is a whole block of code, this one. Okay. So I'm passing this whole block of code here to this method. I know it takes a little bit initial introduction to closer is a bit difficult. How do you pass a block of code, right? But that is what is happening in Groovy. You can define a block of code as an object. Okay. So you're passing this whole block of code here as an object. So this C is not just simple C or it's not just 10 or 20 for that matter. It is actually a block of code here. So this whole part of code, this whole thing will actually go here. Okay.
Yeah.
Yeah.
So it will print 200, I guess.
Yeah. So when you do this C on this num on this C, it is just like we did here C5, right? It is just like this thing we are doing internally inside of the method. Okay. So this num, the 20 that we have passed will actually work on this whole piece of code here. Okay. So let me delete that before it gets ugly. So if I uncomment this part of code again, and if I run this here, okay, so this is 200. Let me just comment this one. Yeah. Okay. Any doubt here? I understand this is frustrating. For initial introduction, it will be that way only. The idea of passing a block of code is very not normal to be honest. But this is how closures are actually working Groovy. You can pass it to a method and then that number, the whatever else parameter can act on that thing and it will give you certain results. Okay.
See, as long as I know the closure, then I know what to pass to, right? So suppose a closure is imported from somewhere.
Yeah.
How do I know what to pass and others, right? So typically happens when you import from a third party and you start using their closures, for example, right?
Yeah.
Then how will you know what to pass and do they give a Java doc sort of stuff?
And they will have to give it, or else how will we know as a their public API should be very clear, right? That okay, you can pass a closer, but their closer should also have let's say clarity that this is what we are expecting, whether we are expecting 2 arguments to my closer, whether we are expecting no arguments. Okay. So that they have to the API should specify that clearly that yeah, this closer expect these things.
Okay. And the parameters which goes to this method, right? It need not be both need not be related to closer. For example, right? It can be num
Yeah, absolutely, absolutely. Why should it be
Need not be related, right?
yeah, absolutely. So you can just go ahead, you can do num star star 2, which is for example, for power, right? So 20, we are passing here 20, right? So 20 to the power of 2 would be how much exactly? 400, right?
Yeah.
And then you can pass it to a closer. So this will be 400 times 10, which would be actually 4,000. So if you run this piece of code, it should give you 4,000. By all means, you can pass even more things here, right? So you can say int, even some other things, string, right? String s equals. I'm not going to change my method call, so I'll give a default value of random text, random something. Okay. So yeah, you can work with s whatever way you like. Maybe you can do some string uh, um, modification or whatever. It doesn't have to be passed to the closer. I'm just showing it so that it is clear to everyone that we can use closer for some very interesting things in Groovy. Okay. All right. Is this clear to everyone? Because let me get rid of this. Is this clear to everyone?
So just correct me, Saurabh.
Yeah.
So it's nothing but you passing an object. So the method, the definition of a method there, right, on the first line.
Yeah.
It is as good as in a Java terms. You have a one data type, int data type, and you pass another object.
Yeah.
That's it. So you do an operation of an object. Typically.
Exactly. But the thing is, with an object, you get two things, right? You with a normal object, you have, if you have an object, right, you have some data to it and you have some behavior to it, right?
Correct. That's
But
right.
with Groovy closures, it is basically behavior. Okay. So it is a piece of code that you actually want to execute on certain things. So it is just the behavior part, not the data and behavior both. Okay.
Behavior is nothing but the property.
Behavior is nothing. No. It's a behavior. Okay. For an object, let's say you have, okay, this is going object oriented now. Anyway, let's just show a quick example here. So behavior, and this is first is data and the second is behavior. Okay. An object consists of these two things. So what is data? Well, the data, for instance, let's say I have a person object. So what could be the data for this thing? It could be the name, right? It could be name. It could be his or her address, right? These two things are data. Okay. Behavior is something like eating, right? A person eats, a person sleeps, right? These are behavior in object-oriented concept. Okay.
Okay, so in that case, whatever we achieve a method of an object, you pass an object as a parameter to a method, and you use that instance of that object, its methods to do some operation.
Yeah, you can think in that terms. Yes.
Okay.
Yeah, you can think in that terms.
Fine, thank you.
Okay. Is this piece of code clear to everyone? This one right here. Hello.
Yes. Clear, sort of. Yeah.
Okay. One more thing here is there's something called as if the closer, like this here, if the closer is your last argument. Okay, I've already told you guys this thing. If the closer is last argument to your method, right, then you can go crazy. If you see your API, you can do something like method, and I'll pass here 100 or maybe 1,000, right? And then you can pass it this way also, right? Like we have seen it on line number 11, right? But you can define a closer here, something like this, okay? And then you can invoke that there. So maybe I'll just copy this thing here. Okay. And if you run this, it will be again here. Sorry, I took a very large number, and that's okay. So if it is the last argument to a method, you can directly define it here, okay, and you can call it that way, your method. So don't think that I'm only passing 1000 as the parameter to this method. This 1000 is passed, and then I'm also passing this closer, okay, this whole block of code. And this is what I meant by when I said anonymous block of code. I don't need to name my closer as C or D or anything for that matter. I can just pass this, and this is very this is how you'll actually often see in your API. And they won't put this bracket for you. This what do you call that? This whole. You can also do it, by the way, this way. Okay, so if I run this code, it will work just fine, but you won't see this in documentation. So I wanted to mention this one, that if closer is the last argument to your method, then you have an added flexibility of calling your method this way. Okay, this is very prevalent in API. If you go through your Groovy API or eBBCS API, if closer is the last argument, then this is how you'll see the call to your method, and it will feel like, oh, I'm defining a method or what here, but you're not defining a method. You're just calling this method, and this is a parameter to that method. Okay, so I hope that makes sense. All right, any doubts so far?
It's really confusing, particularly the 15, 16, 17 lines.
Yeah,
right?
it is confusing. I just wanted to mention this fact because if you read API of anything related to Groovy, and there's a lot of closures, they'll call a lot of closures, and they won't pass it this way at all. They won't do this thing. Okay, they use this shortcut. Okay, and this feels like, oh, I'm defining this method here, but in actually what we are doing is we are passing this as the first argument, and we are passing this as the second argument. And God knows what will happen if you don't have a first argument here. Okay, so if you don't have this, only if you have a closer, let's say, and then let me get rid of this, and I'll just pass here maybe 110 or something. Okay, if you don't have that, no. Okay, so what will this do exactly is, let's see, let's run this thing, right? Sorry, I messed up somewhere. Okay,
There's a method, yeah.
yeah, I have to go, yeah. So if you don't have another argument to a method, and the only thing that the argument is only argument that the method is having is closer, right? Then you have the luxury of calling it this way, okay, without using a parenthesis. Okay, and this looks very different actually. Okay, if you don't use a parenthesis, this looks like, oh, I'm defining a method here, and this method will do something, but in an essence, you are actually passing this whole block of code as an argument to your method. Okay, so be very careful when you're reading API, your documentation, Groovy, eBBCS, this is used a lot actually. This particular syntax. Okay, is it clear for everyone?
Yeah, sort of.
Yeah. Okay. One more thing I wanted to say. I'm defining one closer here, let's say, and by default we have this thing print line it, right? By default you'll have this thing. So if I call close, okay, let's run this thing. It printed null, okay, but I can also call this thing, right? I can say hello, and both will work, right? Because it is implicit, like I've told you, it's implicit. Okay, so first it printed nothing, and okay, and then, but if you call this with more arguments, let's say hello, and then some other text, okay, this will not work actually. Okay, because there is no closer that you have defined that is actually accepting two arguments. Without argument is fine, with one argument is fine, but you don't have a closer that says here something like argument 1 or argument 2, and then you work on those things. Okay, you don't have this. Okay, so be careful with that. Another thing I wanted to show one quickly is that by default I'm telling you that it has one argument, the implicit one. Okay, but what if I don't want an argument with my closer? How do I achieve that part, right? So if I'm defining one closer like this, let's say, then even this call or this call, 1 2 3 whatever, let me get rid of this. Okay, so these are both valid currently. Okay, both are valid here. If you're not passing anything, that's okay. If you're passing something, it will take it as that implicit it that we have defined, that and that I told you earlier. Okay, but what if I don't want to pass any argument to my closer? Well, in that case, you have to do something like this. Remember how I told you the separator before that you pass the list of argument and after that you have a block of code? Well, if you don't want to pass any argument to your closer, you can do this closer. This will work fine, but if I give this any parameter now 1 2 3, this will not work. Okay, missing method exception, it will tell you. Okay. What else? Is it clear for everyone?
Can you show the last one again? Can you do a Control Z?
Yeah.
So why did it not work? The line number 7 says you're defining a closure
Yeah.
with a parameter, right? With one parameter at least, right?
No. When you're not giving anything here, okay, this line separated here. If here I have not given anything, right?
Yeah.
So by default, Groovy will assume the implicit parameter if you don't give anything. Okay, by default. So when we're doing this, no, we will set something like print line it, right? It, okay. Let me comment this part for the timing. So when I'm not giving anything, okay, implicitly it took this it parameter. Okay, so if you run this piece of code, first it printed null and then it printed 1 2 3 because that is what we passed. Okay, if you don't want to pass anything to a closer, if you don't want any parameter, even the implicit one, okay, you just give something empty here and then this line separator. Okay, once you use this line separator, no, that implicit nature will not work anymore. Okay, once you use this line separator. So what I mean, if I run this, sorry, no, if I run this piece of code, it will blow up because here it was working fine, the first one. Okay, this is working fine. It is saying, okay, I'm not accepting any argument, you're not passing me any argument. But when you actually pass an argument, and we have mentioned here that I don't have any parameter to work on this side, okay, then it will fail in that case. Okay.
So to make it work, probably you add a string. And that would start working.
If you add now, the moment you use this operator, okay, and if you pass here something, let's say num, okay, and even if you're not doing anything, like here, even if you're not doing anything inside your closer, like there's nothing inside of this string, right? This closer, okay. So if I execute this way now, okay, this will, okay, what happened here? This property. Okay. Okay. 1 second. And this is this is where I'm expecting this to fail actually. Yeah. That's what is working.
This is correct, right?
Yeah, this is actually working fine.
It should work only, right?
Yeah, it should work. I'm just getting confused a bit. Yeah, this is working fine. Why it is working fine again? Even when you're passing nothing,
So because it's taking empty argument, right? So
and that implicit one, it is working with that one. Okay, like we did this one here. Okay.
Can you pass the string to it? Can you, instead of 1, 2, 3, put it on a string 1, 2, 3?
Yeah, sure.
Will that work?
Yeah,
It will work. It will
yeah,
work.
it will work. It will work.
Okay.
This will work fine.
Okay.
You can go ahead and do write some block of code here. It will work fine. Okay. One last thing about closure I do want to discuss is you can also have a variable number of argument that you can pass to your closure. So if I have a closure this way, right, and then I do something like string args, right, and then I can do something like you can do something like args dot join, and then this join is a method on string, by the way. So something like this. Okay. So if I have a print line, okay, what I mean by that, I'll just show you in a moment. So I'll say maybe you can pass one argument, okay, and you can do this part here. You can pass multiple arguments as well. So maybe I'll change this to marker. And then some random stuff here. Okay, so if you want to pass multiple arguments, you can also do using this thing, using 3 dots. Okay, so this
separator should be there, I think.
yeah, I forgot this thing. This is why. Yeah, thank you. Yeah, so when you're passing just one argument, there's nothing to join, so it just printed this thing. When you're passing 2 argument, it joined using 2 argument. You're passing 3 argument, it will join using 3 arguments. So this is whenever you want to pass multiple arguments, okay, you can do that 1, 2, 3, 4, whatever you want. Okay, so that is there for us to one advantage. You can use this, by the way, in methods also. So you can define a method call, and inside of that method you can say, hey, I don't know how many arguments I'm going to pass, so something like this, and then you can work on this. You can pass 1 argument, 2 argument, whatever you want. Okay, so this is actually called as var args, variable number of arguments. Okay, so that is there. Okay. There's some concept of should I go more in closures or should I move on?
Yeah, please.
Should I move on to some other topic, or you want even more stuff on closures?
I'll say let's move on from closes.
Okay, okay. So let's start with something called as collections. We'll start with collections. Okay. So first thing is there's something called as ranges in Groovy. Okay, range again is an object. Okay, and it is used as a sort of an iterator. Okay, so what I mean by that, so let's just do quickly some example of range. So I want something from 2 to, let's say, 8. Okay, if you're using 2 dot, it becomes a range. Okay, and if you run this piece of code, it is a range from 2 to 8. Okay, so you can do I know that this is just printing 2 to 8. So if I call a method on this thing saying, oh, do you have 5 in it? Okay, and if you run this, okay, do you have 5 in it? Okay, so when I said this 2 to 8, it is actually a range starting from 2 all the way through 8. So 2, 3, 4, 5, 6, 7, 8. Okay, so anything in between will be in that range, inclusive of this 8, by the way. Okay, if you don't want to include that, there is this, you can do something like 2 and 8. And if you write contains here on 8, then it will fail. It will say, no, 8 is not there. Okay, if you write 8 here, by the way, this one, so it will say, yeah, true. So this is actually called as a half exclusive range, and this is a range in general. Okay, and if you want to go from reverse side, so you can do something like 8 to 2. Okay, so this will start from 8 and come down to 2. Okay, and we will use this in iteration actually. So let me actually show you in a quick example how we can use this thing. So I know that we haven't spoken about looping and all those things, but let's start with this. For element in so I'll pass my range here, let's say 2 to 8. Okay, and there's nothing fancy going on inside this loop. What I'll do is I'll just print line lm. Okay, and what it will do is it will print from 2 to 8. Okay, so range, basically you use it as an iterator. You use it for as an iterator. So we have seen earlier also, you can do reverse in range. So if you do lm in 8 to 2, it will just go from reverse. Okay, print line lm. Okay, and if you run this piece of code, it will say from 8 all the way to 2. And if you don't include this this thing, if you make it half exclusive range, it will not be including the last element that you provide. So it will be 8 through 3. Okay. And one important thing about ranges is that they have a very low precedence. So what do I mean by that? If I write something like 2:4 plus 6, okay, so what do you think will happen? This range actually has a very low precedence. So what I mean by that is that this thing will get evaluated first, and then it will become a range from 2 to 10. So if you run this piece of code, it is a range from 2 to 10. So always use parenthesis when you're using a range. Okay, so
Saurabh, what will happen if you print line number 7 with println statement? Like,
okay, if you print line this thing, right? 8 to 2. This is just a range. Okay, it will say 8 to 2. It will not print you whole thing. It will not, it's not a list. Think in that terms. It will not say, okay, I'll give you 8, I'll give you 7, I'll give you 6. It is just a range, and if you query on it, like whether 6 is there in your range or not, then it will tell you, yeah, it is there. Okay.
okay.
So this is actually effective when you're having, so I can have, okay, let us have something. So I can have here a range here. So let me define a range. A equals to, I'll define a range here, let's say from 1 to 1,000,000. Okay. And this, don't think that A will have 1,000,000, A will occupy 1,000,000, what do you call it? 1,000,000 elements in your RAM or something like that. This is not a list. So if you run this piece of code, okay, it will just show you, okay, I'm from 1 to 1,000,000. And if I iterate on it, it will, each time it will call something called as next method or the previous method, depending on whether you are going forward action or reverse, it will call that one. So if I have something, again, what I mean by that, lm in range of 1 to, let's say, 10. Okay. Print line lm. Okay, so it will print from 1 to 10. And we have seen this earlier also. But why I'm saying this is even if you have a million here, this one, okay. Don't think that a million numbers are now in memory. Okay, it is not. It is just a range. It is just one object, and each time you iterate on it, each time I'm saying get me the next element, it will just fetch that next element for me. Okay, and there is a difference between a range and a list there. Okay. All right. So five, let's say 10, and for each of them, okay, again, for each of the element, right? Now each is a method on range which actually accepts a closure. Okay, for each of the element, do what? Print line lm times 10, let's say. Okay, so if you run this piece of code, okay, it will print you 50, 60, 70, 80, 90, 100, and then it printed the range. Okay, so that is actually a range. You can use it to work on your methods such as each, and there are a few more methods on ranges, but you'll get the idea of it once we actually start with lists and something like that. Okay, is it clear? Range, by the way, range is actually an object. So if you have 1, 2, that's a 3, and then you get the class of it. Okay, so this will actually give you Groovy.language. It is a part of int-range class. So Groovy's range are actually objects as well, just like your closure. So you can pass it to a method, you can get it returned from a method, something like that. Okay. Let's now talk about this. Any query? This is very short introduction to range, and there's nothing more in range actually. It is just like I'm out. So I want to work on a number from, let's say, 100 to 200. Okay, so instead of creating a list like this, let's say L equal to, you give 100, then 101, then 102, and all these things like this. Okay, all the way till 200, right? Instead of creating a whole list like this, you can say, hey, just give me a range. So duck range, something like this. And then I'll say, okay, I want to from 100 to 200. Okay, I want to work on data from 100 to 200. And then I can just loop on this thing, or whatever I want to do for LM in range, right? I want to do maybe every time I'm doing this, print line something like lm times 2, power of lm times 2, something like this. Okay, and this will square all the number from 100 to 200. Okay, this is more memory efficient, by the way. Is it clear? That's fine. Hello.
How do you iterate the values of the range?
Okay, so behind the scene, something like this is being called. So range dot next, something like this. So behind the scene, something
Same as iterator.
Same like an iterator next. And if you're having a range from, let's say, 200 to 100, right? 200 to 100, it will be something like range or previous, just like we have an iterator. Yeah, something like this. Yeah.
Okay, thank you.
Saurav, can we pass members? Like, can we pass parameters to the range?
No. Range is just an object, but you don't pass parameters to it. It's not closures. Range is more like how you have list or dictionary maps and all those things. Range is more like that. Okay.
Suppose I want to build a dynamic range. So can I pass a parameters? So you can't do that.
dynamic range as in, so you have, let's say, a variable equals to 10b, and the b equals, let's say, 100, right?
Yes,
And you want to do something like a to b.
yes.
Yeah, this would work, no?
This will work. Okay.
Yeah, this will work. This will work perfect. It will work perfect.
Okay. A to B. Okay.
Yeah, a to b, and yeah. So that is this.
Can we have like string ranges or no?
Yeah, I forgot about that. Good question, actually. Yes, there is string ranges. You can have double ranges. So you can also do something like, let's say 0.1. Give me the range from 0.1 to, let's say, 0.9. Okay, and this is actually a range from 0.1 to 0.9. So you can do something like, for each, again, let's just print line. Okay. No. I'm sorry, I need to pass something here. Hmm. I think I'm doing something wrong. One second.
You are not using for loop, right?
Yeah, I'm not using for loop. I'm using actually each method on ranges. So that's, one second. Each range in Groovy. So this is your range object, right?
Maybe contains.
No. One second. Okay, instead of each, I'll use for loop for the time being. But this would work. I'll get back to this one. But now you can use it using this part. Let me just copy this. You can use for loop. It should work with that also. I'm not sure why it is not working. You can simply say print line alarm, and this will work fine. Yeah. One second. Okay, this is working for a string. So it should also have worked here. So let me just try that one.
Will it work? Will it work for dates as well?
Yeah, it will work with it. Just give me a moment. Print line. If I'm running this particular piece of code, yeah, it is working that as well. And it will work for dates as well. So if you have, let's say, if this is how you actually, we'll discuss dates later on. But if you want to iterate from, let's say, from today's date to, let's say, next 10 days, okay, then you can do each and then print line it, and just run this piece of code. This one. No such example. No such property print line. Okay, because we did this would be curly braces, not the simple parenthesis. Okay. So this will work as well with it. So you have dates from today all the way for the next 10 days. Okay. So I'm not sure why it is not working with decimals. It should work with double as well. We'll check on that. Okay. Any question here on ranges?
No, sir.
Okay. So let's start with lists now. Lists are actually similar to your arrays, and but we have more flexibility here. Okay, in Groovy. Let me get more. Yeah. So this is how you define a list. So def, you'll say list equals to this square bracket. Okay. So this actually defines a list here. Okay. And if you just printed the type of the object that this list is, you will see that this is actually an array list. So this is an array list. Don't worry about if you don't know array list. Using a list is more important. So we can define another list. This is just an empty list, by the way. So if you did something like list dot size, size is used for figuring out the size of a list. Okay. So if you run, it will say 0. You can define another list. List 1 equals something like 1, 2, 3. Okay. And on list 1, you can do something like list 1 dot size, and if you run this one, it will give you 3. Okay. And just to be clear, list in Groovy is not. It is actually heterogeneous in nature. So what I mean by that, if we can have, we don't need to have only integers. Okay, not like how you have in Java, where you have only a certain type of object in your list. You can go crazy here. So you can have 1, 1.2, you can have a date object here, you can have a string object. Okay, so this is also valid in Groovy. You can actually have heterogeneous data in your list. Okay, so that is another thing about list. All right. And just like a string starts from an index of 0, you have this list also starting with an index of 0. So if I wanted to fetch the date, for instance, this is at index number 0, 1, 2. So you have to give something like 2, and this will fetch you list with second index of this particular list. Okay, which happens to be the date in this case. Okay. There's you can convert a range into a list if that is what you want. So if list, 1 second, def list 3, let's say we have a list here. Okay, and I defined a range here, 1 to 1,000. Let's say 1 to 1,000. Okay, you can convert this using the toList method. Okay, and this will actually work. This will actually convert this particular range to a list. So if I said something like list 3 dot get class, okay, then it will be array list. Okay, and it will have all things from 1 to 1,000 in this list. Okay, note that list will consume more space because lists are not like ranges. Ranges is just one object. Okay, list is also one object only, but it list will have all the things from 1, 2, 3, 4 all the way up to 1,000 in memory. Okay, so that is one more thing about list. Any doubt here so far? Okay. You can also have there are a number of methods that you can call on your list. Like if you want, you can add a list to another list. So let's say I have a list 1 here. So let me define it this way. List 1 equals to I have 1, 2, 3, something like that. Okay, and then I just want to add something like L1 dot add all. There's a method add all. Okay, and if I did something like 4, Okay, and then we go ahead and print it out as one. Okay, this will have that method. This will have both the lists. So 1, 2, 3 already, and then you added this. So even if we had something a huge list, maybe three more elements in that. If you did something like this, it will have all the list, all the data from 1 to 6. Okay, so this way you can add. Another thing I want to mention here. Let's say you have a list, 1, 2, 3. How do you add a number to this list? I'm not saying add a list. I'm just saying, can you add just one number? So you can do this in multiple ways. You can do L2 plus 4, and this will work just fine. Okay. You can also do a method call, which is actually L2 dot add 4. Okay. And this will also work fine. Okay. L2, it returns true, but if you just print it L2 again, it will show you that 1, 2, 3, 4, 4 has been added. And then there is another way you can append to your list. This is actually the Luxipt operator. So you can give here 5 and then print L2. Okay, so this should have 1, 2, 3, 4, 5. Okay, so that is just another way to add to a list. Okay. Any doubt on this?
Can we add to the first position?
Yeah, you can do that. There should be something maybe L2. I'm not sure about the. Maybe let me just check. Can we? Do they have something like 10? To do again. Let's run this. It is saying there is no such method as append to a list. So on the other hand, no. Okay, we'll have to check the API for that. I'm not really sure, but I think you can do it. I don't have the method right now with me. We can Google this part. You can add it to a list. I think at any index. Let me just 1 second. L2. This one actually replaced the one. Okay. I think this 1 second. L2 dot and this will be overloaded. 0 thing. Let's run this part. Yeah, you can do this. And this add is actually overloaded. So if you just pass it a number, it will add to a end of the list. And if you just use index-based approach, so I'm saying 0th index, just add 100. So this added 100, and then you have the rest of the list. Okay.
Okay, sir.
Yeah. Okay. So yeah. Actually, it's almost the end of today's session. So I don't want to go in depth with list and maps and sets. We have a lot of collection stuff left. If you have any doubts so far, can you just go ahead and ask some queries regarding what we have already taught today, learned today? We'll discuss the list and sets and maps in our next class. There's nothing much to it. It's very fairly simple. It makes, by the way, this list and everything, it makes it a lot easier, I would say, than working in, for instance, in Java. Okay, so everything actually is simplified in Groovy. So we'll discuss collection framework maybe on Monday. Okay, but if you have any doubts, go ahead with your doubts.
Saurav, one question here. So regarding the closure, so you were having that argument, right? So no argument closure.
Yeah.
So do you have any real-time use of that?
Closures are basically for no argument closure, you're asking?
Yes, no argument closure.
Oh, I just wanted to show it actually. There's no use of it. But if you think that implicitly it actually passed that IT parameter, right?
Yes, yes.
If you just want to test it that my closure should not have any argument, something like that, okay, then you can go ahead with that. Just add your separator, but don't give anything. Okay, so there's that.
Okay, okay.
Yeah. Any other question? One thing also I want to show you guys this thing. So we have used this thing, right? We have used this as well, but you can also do something like a equals to 10. Okay. This is also valid Groovy. Okay. Print line A, and it will tell you that it is 10. So what is the difference here exactly? What is the difference here exactly? This, when you don't define anything, like def keyword or in string, whatever, right? This A is actually, this A will become a global variable and so on in for this particular script. So if I have a method here, let's say def func, okay, and I'm not passing anything here, okay, I'll just say print line A, okay, and if you run this piece of code, it will print you 10. It is happy to print you that. But if you did something like, sorry, if you did something like int equals to 10, and if you tried, I didn't even call it the first time. Okay, so if you did something like this, okay, it is happy to do it for you. It is saying, okay, I know what A is. I know what A is. A is for standing for this particular thing. Oh my God. A is for 10. Okay, but if you mention def, okay, and if you then try to run it, what? It shouldn't actually work this way, man. No. Really? Actually, if you just leave it this way, no, this becomes actually global variable. This shouldn't work here. Let me actually just pass A or something int A, and then we'll just pass here 10, make this 5. Okay. Let's run this part. That's 10. And if you pass okay, I'll actually discuss this next class. This shouldn't work this way. When you don't define it, this becomes global variables. Okay, I'll discuss this in the next class. Any question before this thing? This global and all those things. Any question in ranges or any question in closures?
Can you get one practical example of closure and Collection, yes, we know, but on the closures, right?
Mhm.
If you take a existing code and you can just analyze that and show it, that would really help.
Okay, on closures you want?
Yeah, on closures, yes.
Okay, I'll try and figure it out. Some real world example with closures. Okay, maybe
Yeah.
I'll try to get an example for that one.
In
Yeah.
our EPM Groovy business rule, closures are used a lot. So on last day, you will see a real example.
Okay, thanks, Avinash. Yeah.
Anybody any doubt? Except for this one, this last thing, this is actually messed up. Except for this one, closures and ranges. We didn't discuss list in that depth. We cover it up in the next class.
In EPM, we lot of times iterate over a grid where the cells are edited, right? So where their closures are very useful, where you iterate over a grid where the cells are only the edited cells are there. So there you iterate over all the cells with the help of this closure. So you will see that on the last day. So real life example.
Okay.
Anyone any doubt? Okay, I'm stopping this recording.